Welcome back. Today we're going to learn about logarithms, and as we're going through and learning about logarithms, it's really not that complex of a topic. Although the one thing we know is that currently, if I asked you to solve 3 to the x equals 10, you probably do not have the ability to do that. And so when we're dealing with that problem, it sounds a little crazy that we've gotten this far in our mathematical abilities, and 3 to the x equals 10 gives us fits. Now, some of you might say, well, I would just graph 3 to the x and I would graph 10 and I would see where they would cross, and that's good. But you know, long before graphing calculators, they came up with logarithms. And so we're going to use logarithms to teach us how to solve that type of a problem, 3 to the x equals 10. And by the end of this, I hope you're ready for that. A logarithm of y with base b would look like this, and you'll see this on your calculator. But if you see log of y base b would look like that. And you might say log of y base b equals x. Now here's exactly what that would mean. That would mean that b to the x power equals y. All right. So y equals b to the x would be the log of y base b equals x. Those two things that mean exactly the same thing. So how can I use that in my equation up here? Well, my base then would be the log base 3 and of 10, right, equals x. And now I still don't have the ability to do that because I'm not really sure right now how to do logs of different bases. You will see a log button on your calculator, but that log button is only for common logarithms, which is up next, and those are logs in base 10 and base 10 only. Okay. Now you can look up a lot of things, and I'll put a couple things on the website about why we use base 10. We really use base 10 because we have 10 fingers, and that's how we count. There's been all kinds of different bases that have been used in society, and we have binary text, which is used in computers and all kinds of things. But we're going to use base 10 because that's what we've learned our whole life. Natural logarithms, that is going to be with base e, and we'll talk more about what base e is later. But essentially it is things that grow in nature, base e. All right. I guess we're late for class. Let's take a look at the definition of logarithm with base b and see if I can explain that a little bit more. I think we've already kind of done this, but you know, this would be log base b of y equals x, and then if and only if b to the x would equal y. Okay, until you read that as log base b of y. I can write a little bit better there. So if I rewrite these in exponential form, and that's be the first part of your homework, well, they'll ask you to rewrite them in exponential form. And to rewrite them in exponential form, the log base 2 of 32 equals 5, that would simply be 2 to the 5th power equals 32, and that's a true statement. Okay, and the log base 7 of 1 is 0. That's 7 to the 0. Anytime a log equals 0, the answer in here has to be 1. 7 to the 0 or 10 to the 0, whatever to the 0, that's going to have to be 1. And 13 to the 1st power, that equals 13, and that makes sense to all of us. And 1/2 to the negative 1 power. Now remember, if you have something to a negative exponent, it just flips it upside down. So 1/2 flipped upside down, that would be 2. And that's how you would rewrite those in exponential form. So if asked to rewrite them like you will on your homework, you're going to say 18 to the 0 equals 1. So the little number to the answer equals whatever this was here. 2 to the 6 equals 64. And we'll show you how to do those in your calculator in a little bit. Let's mosey on down the page here. All right. You guys, that was your checkpoint. Let's take a look at example 2 here on the next page. Evaluate these logarithms. 3 to the what is 81, essentially what that's asking us. So 3 to the x equals 81. So 3 to what power do you think that is? Well, 3 to the 1 is 3. 3 to the 2 is 9. 3 to the 3 is 27. Oh, there it is. 3 to the 4th power is 81. So 3 to the 4th power is 81. 4 to the what power is 0.25. Well, 0.25 as a fraction is 1/4. So 4 to what equals 1/4? Well, that was -1. So we put that right there. And this is a lot of guessing, and we're going to kind of take out the guessing later on in the section. But right now, they're just trying to check your number sense and see where you're at. 1/4 to the what power is 256. Well, that's going to take a lot unless I flip it upside down. And if I flip it upside down and call it 4, so whatever my answer is, I make it negative, so it flips it upside down. 4, 16, 64, 256. Well, 4 to the 4th is 256, so 1/4 to the -4th is going to give me 256. So the answer here is going to be -4. 49 to what power gives you 7? Now that's getting smaller. Now that's a tough one. What makes stuff smaller? Well, if I take the square root of 49, I know that that's 7. So how about 49 to the 1/2 power? And if I take 49 to the 1/2 power, that would give me 7. So just some number stuff that you're going to have to do. Take a minute and do 3 and 4 by yourself. Ready? Go. All right. Hope you paused it there. 1/3 to the what is 9. Well, again, I'm going to have to flip it over and make it 3. And we're going to make it 3 to the 2nd power. And 3 to the 2nd power would be 9. So this is going to be -2 as an answer here. All right. And 16 is getting smaller to 4. That's 16 to the 1/2 power. I hope you had those right. All right. If you didn't, don't worry too much about it. We'll go over more of that when we put some actual numbers to it. Let's figure it out. These ones here are a little bit tricky. You just gotta kind of not read so much into them, is I guess what I would say to people. If 10 is to the log, and remember log is base 10, the 10 and the log kind of eliminate each other because, and it's just a simple rule we have that this is always going to be whatever it's to the log of. Because there's a little 10 right here, it's a log base 10, those two things are offsetting. So that one's a little easier. This one here, the log base 2 of 16 to the x. Well, 16, I'm going to rewrite that as the log base 2, put a little 2 down here. And I'm going to call 16 2 to the 4th to the x. Okay? So it's a log base 2 of 2 to the 4x, because the 4 gets multiplied there. So if I have a log base 2 of 2 to something, anything, 2 to the 4x, well, I have a rule that says if I have a log base b to the x, those things are offsetting, and therefore my answer here is simply 4x. And so if you can get the base and the number that's inside the log there to be the same, then you're going to be all set, because then you'll have 4x. So let's take a look at that in an example form here. And we got a checkpoint coming up, so be ready for you to answer these questions. Find the inverse of the function log of 3/2 to the x. Now, from what we remember doing inverses, you flip-flop the x and the y, and then you solve for y. So I'm going to call it x equals the log base 3/2 of y, and I have to solve for y. So if I'm trying to get y by itself, I'm just going to rewrite this in exponential form and say 3/2 to the x equals y. So y to the 3/2 equals x right here. So I just rewrote it in exponential form once I flip-flopped the x and the y. And so remember, they didn't really explain that very well here. take a look at this one. Y equals natural log of x minus 4. Well, the x here that we have natural log, remember that's going to be base e or log base e. We're going to switch the x and the y, so now I have x equals the natural log of y minus 4, right? And because this is log base e, natural log actually means log base e. All right, sorry for my terrible handwriting. So e is here, and we're going to say e to the x equals y minus 4. E to the x equals y minus 4. I still have to solve for y, so I'm going to add 4. So I get e to the x plus 4 equals y. Therefore, the inverse of this thing is e to the x plus 4. You guys go ahead and take a poke at 5, 6, 7, and 8 real quick. All right, welcome back. I hope you saw that this was 7x. I hope you saw that those were offsetting. 27 is simply 3 to the third power. So that's 3 to the 3x. And so if I have a base 3 and I have this 3, then they offset and I get 3x again. Find the inverse of this, so I flip-flop my x and my y. And if I get x equals 7 to the 2y, wow, well, remember we didn't have the skills to do that before, but now we do. Now we know if I can do a log base 7 of x, that's going to equal 2y. Remember, 7 to the 2y equals x. And then if I divide that whole log base 7 by 2, log base 7 of x, all divided by 2, that's going to give me my y. And I take a look at this one here, and I flip-flop the x and the y again, and it is almost identical to this one right up here. So when we do it, we have x equals natural log of y plus 6. That's going to be e to the x, and then we're going to minus 6 from it. Minus 6. That's going to equal y. So I hope you guys got those ones. Let's take a look at the graphs of these log functions. The graph of y equals log base b of x is shown below for b is greater than 1 and when b is between 0 and 1. Because y log base b of x and y equals b to the x are, what would we say? What word would we put here? Hopefully you said inverse functions, because that's what they are, right? Inverse functions. Oh, spelled it wrong. Inverse functions. The graph y equals log base b and x is the reflection of the graph y equals b to the x over which line? Now, if they're inverses, they got to be a reflection of the y equals x line. So they look like this, and you can graph those in your calculator, and you don't have to graph y equals log base b of x. Just do the log of x, and it'll look just like these ones. Remember some things you need to know. The domain of y equals log base b of x, because this is a result of b to the y power, x is going to have to be greater than 0. Remember, you can't get a negative result when you're taking something to a power. Okay, and the range is, remember we do this shorthand, all real numbers. Could be anything in there. Okay, let's take a look. Let's take a look at example 5 here. Change my color up a little bit, and maybe make my markers a little bit darker. See if that helps with my handwriting. So if I were to graph this thing, log base 2 of x, now I don't have that function on my calculator, and later on I'll show you how to do that on your calculator. But to start, we're just going to try to plot some points and see where that goes. And so we have x and we have y. Now if I let x equal 1, 2 to the what power, that's what I'm really asking myself, 2 to the y equals 1. Well, that's 2 to the 0 equals 1. If I put a 2 here, 2 to the what power equals 2. 2 to the what power equals 2? Well, 2 to the 1 equals 2. And 2 to the what power equals 4? 2 to the 2 equals 4. So I end up graphing those points. I graph the point 1, 0 right there, and I graph the point 2, 1 right there, and I graph the point 2, 2, 2, 2, get it? 2, 2, all right, right there. And what I end up getting when I graph those things, and it's not maybe completely obvious to you as it will be later when you put on your calculator, but it looks something like this, okay? Just like that. And if I move down to this next one, 1/3 to the what power is 1. Well, it's always going to be 0 for that one. But 1/3 to the what power is 3. Well, 1/3 to the -1, because that's what's going to flip 1/3 upside down. And then 1/3 to the -2 is going to flip this one upside down. Now when I graph that, that's going to look dramatically different. That's going to be the point 1, 0. It's going to be right here. But then you have some negatives. So we got 3, -1 right here. And we got 2, 4, 6, 8. I don't know. Oh, wait a minute. 2, 4, 6, 8. Here's 9. -2 is right here. And that one that was 3, -1 should have been right up here somewhere. So when I graph this one, it's going to do more like that. It's going to kind of be just the opposite. It's going to flip upside down there. That could have been a little better curve there. When we translate, here it comes again. Once again, we're talking about h and k. And how many times have we talked about h and k when we do these things? Log base 3 of x minus 1 plus 2. Well, that takes that graph, log base 3, and we have h and k. So if you take the log base 3 of x and you graph it, it is going to move 1 to the right and 2 up. 1 to the right and 2 up, just like every hk that we've had ever since we've done this. And so you can graph that whole thing again. If you put a 1 in for x, you're going to get a 0. So 3 to what power is 0? Or if you put a 1 in here, you get a 0. 3 to what power is 0? That's going to be a little bit of an issue, but you can see that we have a 0 there. And then if I put a 3 in there for x, oh, I see what they're doing. I'm with you now. All right, I got you. They're graphing this thing. Let's erase that. There we go. Turn it on. They're graphing y equals log base 3 of x. Gotcha. And then they're going to translate it. So when we put a 1 in there, we got a 0. We put a 3 in there. 3 to the 1 is 3, and 3 to the 2. And so we graph those points. 1, 0 is right here. 3, 1 is right here. And 9, 2, 2, 4, 6, 8, 9, 2 is right here. And so when I graph that first one, look like that. Now I'm going to translate every single one of those points to the right one and up 2. So to the right one and up 2 is 2, 2. To the right one from 3 is 4, up 2 from 1 is 3, and up 1 from 9 is 10, and up 2 is 4. And if you plot those points, you'll see that you found a translation as it moved. And you guys go ahead and do that checkpoint there. I'm going to give you a give you a couple of points that you could have found when you're doing that. So log of 1/2 x minus 1. If you wanted to just translate it, remember you don't have anything inside of the x, so it's only going to move down 3 from the original. So if you just graph y equals log of 1/2 x, and you plot some points, and then you're just going to move them all down 3. So if the first thing you put in there is 1 for x, then you get 0 for y, so you get the point 1, 0 right here. And if you put a 2 in there, that would be that being flipped upside down. So you got 0, or you got 2, -1. 2 -1s right here. And 4 in there is going to be that 1, 2, 3, 4, -2 is going to be right here, because that's going to flip that upside down. And so the graph's going to look like this. Well, if you take the whole thing and shift it down 3, 1, 2, 3, let's change our color so we can tell the difference between our answer and our work. 1, 2, 3 right here, 1, 2, 3 right here, and 1, 2, 3 right here. Our answer ends up being that one, the red one. All right. Thanks, folks. A lot of work, new. I know a brand new topic, going to be tough. You probably had to rewind a couple times, but I really appreciate you sticking with me. Have a wonderful rest of your day.